Thank you for taking the time to attend this session and also for doing all that walk all the way to the Hyatt. Today we're going to talk about how to combat advanced cyber attacks with Microsoft Cloud App Security. My name is Gal Zilberstein. I'm product manager at the Cloud App Security team. And over the last few years or so, I would say that basically every organization that I know is moving to the cloud. And I know that this probably is not surprising for you. But what is surprising, and that's a change that we're seeing in the last year or so, is that organizations move their most critical workloads to the cloud now. I mean, we're suddenly seeing the most critical database now on the cloud, and we're also seeing the most important business application that is now living in the cloud. And when I say the cloud, it can be obviously Azure, AWS, or some other applications. But this change makes a dramatic change also to the way that attackers look at our environment and what they want to do with our assets. Because attackers adapt fast, attackers are super smart, and they're the first to identify that there's a shift in our environment and that our data is now available for them basically everywhere through the cloud. This fact, together with the fact that our environment itself is changing with bring your own device, digital transformation, and absolutely no perimeter, those two facts basically mean that it's super hard to detect attackers when they access our data, but also to take action. Now, we're on Wednesday, so I'm pretty sure that you've seen this slide for like 8 or 9 times already. But beyond just saying that Microsoft runs 200 cloud services and that we're getting telemetry from over 1 billion Windows endpoints, what I want you to know is that our own researchers within the product team use the data from the Microsoft Intelligent Security Graph as part of our detections. This much data basically means that we see each and every, I'm not sure if each and every, but most of the threat vectors that attackers are using. And it can be attackers that are financial actors or some that are nation-state funded. But all of these attacks probably will have evidence in our telemetry. Now, obviously, Microsoft provides solutions and products in all the different security areas, starting from identities, endpoints, user data, cloud applications, and infrastructure. But in this talk, I want to focus about the cloud applications piece. Cloud applications, basically, if we'll think about the right way to attack those or to get data from them, we should take a step back and remind ourselves how a typical attack would look like. Traditionally, I mean. Historically, an attack would usually start with a phishing email, right? That had some malicious attachment in it. It could be an Excel file with a malicious macro. It could be a Word file that contains some, I don't know, Windows 0 days, sophisticated one. And once the victim would press on that file or open that file, the attacker would get root access to his machine. This machine would probably be on-prem somewhere. And then the attacker will start to move laterally across the network until he's able to access all the data that he cares about and complete his mission. Now, the cloud changes that in a very fundamental way, because the attack can still start from a phishing email. But the fact that we have, again, critical data in the cloud means that if, for example, I want to exfiltrate the CEO's emails, the moment that the user account is compromised, basically I'm able to use that account directly to set inbox forwarding rules on that account and exfiltrate all that mailbox, right? So if we'll think about that for another second, basically there's a new concept here, that your entire organization can be compromised today without a single endpoint that was compromised in the process. And that's a very important change, and it also affects the way that attackers look at the cloud when they plan and deliver their attacks. So when I say cloud attacks, they happen across all the different cloud workloads, starting from IaaS, PaaS, and SaaS, and they evolve super quickly. if we'll start with crypto mining attacks as an example, then historically, or when crypto mining attacks started, they weren't very disturbing. People looked at them kind of like, I don't know, the spyware of the old days, where it takes some of your resources, you don't really like that it's there, but it does not affect you too much. But with the rise of cryptocurrency in the last 2 years, we're seeing that these kind of attacks are being super, super advanced. Attackers understand that there's a lot of compute resources out there in AWS, in Azure, et cetera, and they use very sophisticated malware to spread the payload of the crypto miners. So I'm not sure if you heard about the WannaMine crypto mining attack that happened earlier this year, but attackers leveraged very sophisticated malware techniques to make sure that their miners reach to as many places that they can do. And when I say advanced technique, I mean fileless malware, and I mean that they use NSA exploits like Eternal Blue to try and expand. And suddenly, crypto mining attack is something that is much more concerning, and it allows the attackers to basically steal my money, right? Because in the cloud, we pay for each and every resource that we use. Now, another example is an example from the PaaS world, specifically about cloud storage exfiltration. A lot of business applications or enterprise applications leverage cloud storage as part of their work. It can be Azure blobs, and it also can be AWS S3 buckets, and obviously some others. And in the last few years, we're seeing a lot of attacks that make a lot of noise. You see that big headline that is saying, hey, there's a lot of customer data that was leaked, and we think, well, probably there's a huge attack that is happening, super sophisticated technique. But in the case of publicly accessible AWS S3 buckets, it's simply a configuration flaw. It's simply something that our admins did not configure correctly. An example that I like to give is an example from the Time Warner leak that happened last year. Over 4 million subscriber data was leaked, and it was simply because one of Time Warner's vendors misconfigured their cloud storage bucket. Now, having insecured cloud storage buckets, or I would say back in the days where you can have on-prem storage, and it was misconfigured, it was fine. But now when the cloud is publicly accessible to everyone, you must make sure that all of your configurations are in the right place. In Cloud App Security, we invest in those areas of security configurations. I will not touch on that in this session, but just to give you an example, you can see here that we have a policy that identify all of those open AWS S3 buckets. And this is just an example of a configuration thing that we should take care of. Now, for the third example, I want to go back to the SaaS world. And let's talk for a second about OAuth applications. Anytime that you use your enterprise identity, and it can be Azure AD, it can be your Google identity, and you want to use it for with a third-party application, then this application needs access to your information, and it will give you this consent page, right? And this mechanism is a typical mechanism that can also be used by attackers when they want to access our information. So an attack on OAuth applications or on the OAuth flow can start with a phishing email like you're seeing on the screen. This is an example from an attack that happened last year on Google Drive, or on Google in general. And you can see that the email looks perfectly normal, just like someone was sharing a file with me on Google Drive. Now, once I'll hit open in Drive, I'll get to the consent page in the browser. That seems completely legitimate, right? I can tell you that this is the Google page, and also it's signed with the Google certificate. Basically, everything seems fine, right? So I'll give you a moment to take a look and try to figure out what is wrong with this page. Because even though it uses the traditional workflow, attackers can use the application itself as part of this process to get access to our information. So if I press on Google Docs here, you can see that the application itself is not Google Docs by Google, but rather an application by a developer named Eugene Popov. And the moment that I will hit allow on this screen, basically this guy, Eugene, will have access to all my emails, to all my contacts, and he can then go ahead and do whatever he wants with my emails. For example, forward them like we just mentioned before. Now, these kind of attacks happen all the time. They get more and more targeted all the way around, from the initial phish until the application itself, like you're seeing now. It seems super legitimate. And we also believe that attackers will keep using that simply because it's leveraging the normal method of OAuth application. There's no exploit here that is used to access our information. Now, I keep saying attackers, hackers, bad actors, you name it. So let's take a moment to talk about one of them and get to know them better. And the attacker that I want to talk about is the one that initiated that Google Docs campaign last year. And his name is Fancy Bear. Have you heard about Fancy Bear? Can you raise your hand? Great, a few. So Fancy Bear is a very, very advanced attacker group that was linked by media sources like AP and Wired and many others to the Russian government. Some say that they report directly to Putin. And they were involved in some of the most high-profile cases over the last few years. The most notable ones are, in 2016, the attack on the World Anti-Doping Agency, or on the Democratic National Committee before the US elections, and also in 2017 before the French elections, and some more. And I think Fancy Bear represents very good the change that we're seeing that attackers are doing. Because as I mentioned, they are a very sophisticated attacker. It means that they have in their arsenal a bunch, I don't know how many, but a bunch of zero-day exploits to all the endpoints out there. But they understand that they have a lot of interesting data now in the cloud, and they shift to more advanced techniques that are cloud-focused, like the one that we've seen with OAuth. And I think that if Fancy Bear is doing that, then we'll see more and more attackers that are doing just the same thing. Now, so far we talked about a few scenarios that happen in the cloud and why we should be afraid of them. Now let's take a few moments to talk about cloud app security and what we are doing to help you address all of that. So Microsoft Cloud App Security is the Microsoft CASB, Cloud App Security Broker, and it provides you all the visibility and control that you need for your cloud applications. And when I say cloud applications, I mean obviously Microsoft applications like Office 365 and Azure, but also third-party applications like Salesforce, Box, Dropbox, etc. As a CASB, we provide solutions and capabilities in 4 major pillars. The first one is Shadow IT discovery. Basically, as an organization, the first thing that I want to know is which applications do I have that are being used in the cloud. Think about that. Today with SaaS applications, let's assume that someone from my marketing team would like to use Slack for their team. They will just go ahead, put their credit card, and will start to use Slack, right? So while Slack, we understand what it is and we know probably what it does, we still need to have good risk assessment to be able to understand for each and every application that is being used in our organization if we want to sanction or unsanction these applications based on a bunch of risk factors. And Cloud App Security provides you both the discovery for these applications as well as risk assessment to over 16,000 applications within the catalog. Now, once I decided which applications I do want to use in my organizations, which are the sanctioned applications, I still want to have real-time and granular policies that will allow me to control what people are doing within those sanctioned applications. And we're doing that through a component that we call conditional access app control. Basically, it's a reverse proxy that allows us to provide limited session capabilities for those sanctioned applications. So think about your vendor that is using unmanaged devices that we have no control of, but he needs to access our corporate SharePoint portal. So we want him to access that, right? We don't want to interrupt in his productivity or in his work, but we don't want him to download all of these corporate files to his unmanaged device that we have no control of. And these are exactly the type of scenarios that we provide with conditional access app control. The third pillar is information protection. And in these areas, Cloud App Security extends the Microsoft information protection story and allows you to configure DLP and information policies for your data in the different cloud applications. And it can be Box, Dropbox, or others to have really the full story as part of Microsoft information protection. And the fourth area, which is our focus today, is how we detect those advanced attackers, how we detect Fancy Bear and others within our network and our assets. So when we deep dive to how we detect threats, Cloud App Security provides capabilities in different areas, starting from rogue applications, those bad OAuth applications that we discussed previously, and I'll show you that in a demo later on. Moving to malware and ransomware detection for the files in your different cloud applications. And when I say malware and ransomware, I mean first signature-based detection for malware based on Microsoft intelligence, but also behavioral learnings that allow us to identify when there's an encryption process that resonates with ransomware. This is super powerful, and we'll talk about that later on. The third area relates to that. It's data exfiltration, basically our ability to detect when someone tries to get a bunch of information outside of our organization. And usually it will obviously not be to a sanctioned application, but to some third-party application that we don't use. And the last area is malicious insider and compromised accounts, basically all our user activity detections, where we leverage UEBA and advanced analytics to identify whether something abnormal is happening with the users. This is a strong indicator of compromise. Now, I've been talking for, I think, 15 minutes, so let me show you some of it in the portal. OK, so what you see now on the screen is the Cloud App Security portal. This is the dashboard where you get aggregative views to all the different pillars that we just discussed. I want to start by going to the alerts queue, where we see all the alerts from the different areas of the product, and filter it for a specific user. His name is Bill in that case. Now, what you can see now on the screen is that there's few alerts that were triggered for Bill. And if we'll just look at these alerts in the alerts queue, we can already get a lot of insights to what happened with that user. So we can see that the first alert is multiple failed login attempts for this user, which is a good indicator that there's a brute force attempt that is happening on Bill. The next two alerts are activity from a Tor IP address and impossible travel activity. Basically, it means that there was a successful activity from an IP anonymizer, Tor in that case, as well as a connection from a location that you can't travel to in a reasonable time frame. Now, these two alerts give us a good indication that the brute force was successful and that the user is now compromised. Now, the next two alerts, first one is mass download, shows us that the compromised user was used to exfiltrate a bunch of information, this time mass download from our corporate OneDrive for Business. And not only that all this information was exfiltrated, but there was also an activity that resonates with ransomware that encrypts all of these files. So just by looking at the alerts queue, we have a good understanding that something is obviously bad with Bill, and that we would like to take a deeper look at each and every one of the activity that he was doing. So we have a detailed alert page for each and every one of them, where you get all the context that you need to understand what happened in that activity and why we decided that it was malicious. And from that alert page, we can then go ahead and navigate to the activity log to take a deeper look at the actual activities. So you can see here the description of why we thought that it was a bad activity. But then I can go ahead and investigate in the activity log to see all the different activities that are related to this alert, but also to pivot on the data in a very easy way. So, for example, I can filter to see all the activities from the same user, or all the activity from the same IP, or from the same location. And these type of smart filters and smart pivots allows me to really quickly understand whether this is a legitimate activity or whether something is truly wrong with the user. Another thing that I can do is to get additional context on the IP address and the user to see the previous activity and the learnings that we have on these entities. So if we'll take a look at the user, for example, then you can see that beyond the 5 alerts that we've seen previously, I can also see that there's different ISPs and different IP addresses that were used in the last few days, together with a spike in the activity from that user, which is highly abnormal. Moreover, this user is an admin in O365, which makes him a very important target. Now, directly from here, I can go ahead and decide to take action on the user and suspend him or require him to sign in again to finish this process. Now, once I took the action, I can then go back to the alert and decide if I want to resolve it or dismiss it based on the different findings that I had. Now, one thing to note about that, for those of you who already use the product, when you dismiss or resolve an alert, you can send us feedback. You can see here and let us know if you think that the alert was good or not. We're getting this feedback directly, and our researchers use that information to improve the edge cases that we identify. So please use that. It's not going to some loophole that no one looks at, and it's very, very useful. Now let's switch back to the deck. OK, so let's take a moment to deep dive to user activity detections and how is it that we're detecting these bad activities. So we're doing that by combining 2 sets of detection engines. The first one is our UEBA engine, which is based on advanced machine learning. It constantly profiles your environments and creates baselines for the activities of each and every user in your organization, as well as to the behavior of all your tenants. So then when something bad happens, we can compare that, or when there's a new activity, not necessarily bad, we can compare it to the previous activity and identify whether something is indeed wrong. All of the detections in this engine are enabled by default, and you get them out of the box without a need to do anything. And the detections from that engine, the cool thing about them is that we take a look at all the activities of the user across his entire session, across all the applications that he's using to identify when something is wrong. So think about that. We're not only looking at the login that may seem legitimate, but we're looking also to the activity, for example, in O365, after the specific login, to really find the breadcrumb that may lead to a compromise. This is super powerful. And we're seeing very, very interesting breaches that are being detected using that. Now, on the other side, we do understand that for each and every organization have their own edge cases and their own specific scenario that they would like to cover. For example, for some organization, it may be perfectly legitimate to alert on any activity from Nigeria, because Nigeria have a history of a lot of cyber attacks, and some organizations, mostly the small ones, would like to be alerted on each and every one of those. Now, our machine learning engine will not alert on any activity from Nigeria, but only if something really weird happens from Nigeria that is not normal for the tenant. So to address that, you have the rule-based detection, the rule-based engine that you can define on your own to fit to those edge cases. You can say, hey, I want to be alerted on any activity from Nigeria, and to really have that full coverage to all the scenarios that you would like to address. Now, all these detections are based on a few different data sources, so you will really have coverage to all the activities in the cloud. So the first one is API connectors. Basically, we connect to the APIs of the different applications to grab all the activities from them. We're doing that for Microsoft applications. For these applications, obviously, we're first party, and we can affect the data that lies within them, and also make sure that we get everything that we need for detection. But also for third-party applications, we connect directly to the APIs to get all the activities. The second source is Shadow IT Discovery that we use for the detection of Shadow IT apps or for apps that are being used. We also use this data for detection. Basically, it's the data from your firewall and proxy, your organizational firewall and proxy. And the third one is data from conditional access app control or our reverse proxy that I mentioned previously. What you can see now on the screen is all the built-in detections that are shipped with the product. There's some interesting ones that we talked about already, like impossible travel, like ransomware activity. And this year at Ignite, we're announcing 3 new detections that are added to those. Let's quickly cover them. So the first one is data exfiltration to unsanctioned applications. Obviously, exfiltration is a very scary scenario, especially when the data is going to an unsanctioned application that we have no control over. Think about someone that, again, downloads a bunch of files from corporate SharePoint and upload that, like in the example here, to Google Drive, to his personal Google Drive. So this is obviously something that we want to detect and take action on. Now, again, will not alert on each and every case that we're seeing a spike in upload. We'll alert only if this is a behavior that is not typical for the user and is not typical for the tenant, and this is super powerful to reduce the noise that you are seeing. The second detection is suspicious inbox forwarding that we talked about already in a while. It's a very common technique that attackers use just after they're able to compromise different accounts. Now, the thing about inbox rules or inbox forwarding rules is that they can be perfectly fine. And in large organizations, we're seeing inbox rules that happen thousands of times a day, and it doesn't make sense to alert on each and every one of those. So we created a very interesting detection that is able to identify whether something is really suspicious with this forwarding rule. For example, think about a user that is constantly working from, I don't know, Ireland. And then the first activity that we're seeing that he's doing from another location is to set a forwarding rule. Now, this is a strong indicator that something is weird with that rule, and we will alert on that. By the way, this is how setting up a forwarding rule will look like in Outlook Web Access. I'm not sure if you can see, but there's 4 rules that are set on this mailbox. For example, move imported emails to important folder, move newsletters to newsletter folder, delete emails from John. But what attackers are constantly doing to hide the fact that they're exfiltrating data, they just replicate one of the existing ones, and you can see it over here, that move important emails to important folder looks exactly like the first one, just with a 1 at the end. But the new rule that the attacker created will apply to all messages, forward all the messages in the inbox to some random email outside my organization. This is obviously something that we would like to avoid. Now let's move to talk a bit about file detection, specifically about malware. We touched on that a bit before. Basically, with malware detection, we identify files that we think that are suspicious. So we don't run all the files through threat intelligence, but identify files that, for example, are shared widely. Identify files like DLLs that are more suspicious by their nature, and run them. And when I say run them, we run their hashes through the Microsoft intelligence to identify whether their hash is associated with known malware or not. I'll show that in a demo just in a second. The next area is visibility to OAuth, visibility and control to OAuth app permissions. Again, the fancy bear scenario that we discussed previously. Here we provide all the solutions that you need to address those applications, starting from visibility to those applications. Again, which applications do I have in use in my organizations, but also allow you to take action and decide to revoke applications that you think that are bad. And you can do that manually, but now also automatically. You can define those policies to alert you when there's a specific condition that is being met. Let me switch back to the portal to show you how it looks like. So under the investigate section, we have app permissions. Now, when we're talking about app permissions, you can see here that I have the list of all the applications that were authorized by some users in my organization. And for each and every one of the applications, we provide the basic information like the description, the publisher, the specific permission that this application requires. But we also apply analytics on this data to help you understand whether this application is good or not. An interesting one is community use, where we try to identify whether this application is common or not across all the cloud app security tenants. So think about an application. Let's, again, use the smart filters to look for an application that requires for high permission level, but it's also very rare across cloud app security tenants. So obviously, this is an application that we would like to look at, right? Especially if there's a lot of users in my organization that use it, I would at least want to make sure that it's a good application that I want it to be used in my organization. And then also I can take action. Like I mentioned, I can decide that this application is approved, or I can mark it as banned and basically remove all the users that already use this application. It also includes a notification to the end user to say, hey, you was using this application that does not meet the corporate policy, and we decided to revoke it. Now, in large organizations, even for this filter can create a lot of matches and a lot of apps that we would like to monitor. So doing that manually doesn't really make sense. So we can just create a policy and let's call it risky OAuth apps, for example. And for that application, I can define the exact rule that will trigger it together with the action. And the action can be a soft action, like create an alert, send me an email, things like that. Or it can be a more strict one where I can revoke the app altogether. Now, this governance action will revoke the application together with all of its users. So be careful with that one, because you don't want to revoke applications that are critical. But we are currently working on additional controls, more granular, that will allow you to revoke specific users or specific groups when specific rules are met. These are the strength of OAuth app permissions is that in cloud security, you can apply those not only to Azure AD accounts and not only to Microsoft accounts, but also to accounts that you have in Google or Salesforce. Regardless, all of those you can apply those policies. Now, the next thing that I want to quickly show you is malware detection policy that I just mentioned. By the way, this is the policies page where you can see all the policies in your organization. We'll take a look at malware detection. So again, malware detection policy ships out of the box. You just have to enable it, make sure to enable it, and it will automatically start to run suspicious files through Microsoft Threat Intelligence. In this example, you can see that I have 6 matches, 6 files that were identified with potential malware, and I get all the information that I need on the file, who are the collaborators to help me scope the issue of the file, which application did it happen on, and additional detail on the file itself. But the most powerful thing about it is that for most malwares, we also provide a report on the specific malware that gives you all the details on the specific malware and what you should do to address it. It's written by our security researchers. That's an example of ICAR. Obviously, there's not a lot of information about it, but some of the reports are super detailed. They contain information on the actors themselves. So this is another thing that is super interesting. OK. Back to the deck. So Cloud App Security, as you know, is a product that is already out in the market for a few years. And it means that, as such, it contains all the enterprise integration and the enterprise features that you need to integrate with your SOC process, your security process inside your organization. And when I say enterprise integration, I mean, first of all, SIEM integration, so you can forward all the alerts to your SIEM, and if you want to apply correlation in the SIEM, you can do that. And if your analysts only start to handle alerts in the SIEM, you can forward the alert directly to them. Also, obviously, role-based access control. As you've seen, Cloud App Security contains different pillars that sometimes different people manage. So you can define exactly what are the access level that you want each of one of them to have. Global scale, where the service is deployed in multiple regions, and you can decide wherever you want your data to be. But also this Ignite, we're announcing integration with Microsoft Flow. Microsoft Flow is an automation platform that allows you to define automated processes for different scenarios that are specific to you. For example, think about an organization that has 2 different SOC teams, one in the UK and one in Germany. And we want each one of the teams to get only the alerts for their specific locations. So using Flow, we can define a specific process that will redirect an alert to the relevant SOC team based on their location. This is just an example, but the integration with Flow unlocks a bunch of scenarios that we can implement in the future as well. I'll give you an example of something that we're thinking about. Think about an alert that is geographically based, something like impossible travel or a connection from an unusual location, that you will be able to send an email to your end user asking him, hey, was this you that log in from this location? And if he would press yes, the alert will be automatically dismissed with a comment saying the user acknowledged that he was in that same place. So this is just a beginning of an attempt to help you automate the processes that you have inside your SOC and address some of these alerts automatically. Integration with Flow now, the scenario of the 2 different SOC teams that I mentioned is already shipped. The second one is something that we're working on, when you can notify the user. Yeah. OK, so I want to go back to that slide that we've seen previously. And I've talked about all the different capabilities that we have in Cloud App Security in each and every one of those areas. And obviously, we keep expanding those. We keep monitoring the threat landscape for evolving threats, specifically around the cloud. But as more and more sophisticated attackers move to the cloud, we'll probably have to expand that list a bit more. So in terms of next steps, for those of you who don't use Cloud App Security, I highly encourage you to start a trial and see in action everything that I just showed. If you have any questions, we're here at the expo. Please come, ask us questions. We'll be happy to help. And with that, if someone has any questions, we can take it now, or I'm here. Thank you very much.